Hello, everybody. This is Mr. Nam, and I'm going to go over your lesson for today, which is Thursday, September 17th, where we introduce our popcorn phenomenon in case you missed it or you just want a little bit of refresher whenever you are working on this. Okay. For your assignment today, guys, you are going to be turning in this PowerPoint in Google Classroom, hopefully by tonight at midnight. But I'm going to walk you through it. Okay, so the do know that we did today, in case you missed it, is which zoom in model do you think best shows the particles of a kernel in a kernel of popcorn and why? Okay, and we actually did this in the chat, so I'm going to skip going over it. But what should have came up was probably model B because it's not moving, right? It's a solid. The kernel is a solid, so those molecules are pretty tightly packed, and they are not moving around. Okay. So the agenda, we just did the do now, guys, and I'm going to go over the scientists of the day, review yesterday's learning. We had some breakout rooms, which you will have to do on your own in case you missed this, and then I'll go over the independent time. Okay. Our scientist of the day is Dr. Moya McTeer. She is an American astrophysicist and folklorist. She grew up in a small log cabin in the mountains of Pennsylvania. She studied both astrophysics and folklore and mythology at Harvard. She has a PhD in astronomy from Columbia University and researches the way the Milky Way's motion affects planet formation. Okay, awesome scientists. Alrighty, guys. So review from yesterday. What did you learn? Okay, we want to drag these words into the correct box. What you should do, in case you missed it, so do this on your PowerPoint, is solid should go right here. Whoop. To me, the next one, liquid, which has more movement than a solid, but not as much as a gas, should go right there. And gas should go in that last right one. Okay. Remember now, solid objects, their particles are very tightly packed. They're not moving. They're not as fluid and moving as a liquid, and definitely not even close to as a gas. Okay. So if you were to describe what matter looks like and acts like if you zoom in, what would you say for these three? So you're going to type your answer here. What is different about the different states of matter, solid, liquids, and gases? So particles in different states of matter, what's different about them? Okay. I'm going to press Control Z so my slide can go back. Let's keep rolling. Okay. Then what we did was we had an observations video. So private think time. So this was on your own. What did you observe in this video? So you're going to play this video. So this is popping popcorn at 300 frames per second. This is at 30,000 frames per second. Isn't that beautiful? Oh, that was mesmerizing. The same thing a couple of times, a little more dramatic. I'm going to pause it for the time's sake of this video, but what I want you to do is kind of think in your head, what did you observe? Okay, what did you observe? What's going on? Okay. And then what we did was we went into breakout rooms. Oopsies. We went into breakout rooms. Okay, and you're going to make inferences on what you see. So what I want you to do is you're going to type in at least 3 different inferences on what you saw. Since you weren't able to go into a breakout room, if you're watching this, most likely, then you're going to try to answer these questions with 3 different inferences. Okay, and then we did a whole class share out. I called on some of you randomly, and you were typing what your classmate said. If you are doing this on your own, you can actually ignore slide 9, okay, because you are kind of by yourself. Okay, so today's work is you have 3 different assignments for today's work. First, you're going to fill in your popcorn model with particles inside the second zoom in. Then you're going to write in complete sentences what you think is going on. And you may not know for sure, right? Because this is all new. But for the next 2 weeks, we're going to learn about this concept, and it's actually going to change your thinking. These are some questions you can use to kind of guide your thinking if you want. But on slide 11, this is your first part of your asynchronous assignment. So you're going to type in here, this is what the cold molecules are like. So before the popcorn pops, and you're going to type, what are the cold particles like? Okay. Then you're going to go to the second side, and then right before it pops, so when the popcorn is ready to pop, what are the particles doing? Okay, here are some different particles you can use. It's a bank, so you can drag them. Actually, you have to drag them into the Zoom in to show me what's going on. I'm just doing this randomly to kind of show you how this works, right? So I'm going to Control Z. You can change the color if you want to change the color of the particles to represent different types of particles. You can change the size of the particles. You have arrows to show movement or however you want to use those arrows. But you're just going to show me visually what's going on that's different between the code and the popcorn that's just about ready to pop. Okay. Once you've done that, guys, you then have some review vocabulary. So the next pink slides are words that you should have already used in class. Okay, so read them over to review and then do the practice activity. These are your 5 words: matter, particle, states of matter, observation, and inference. Okay. Then what you're going to do is you're going to drag each of these words to match the definition. I'm just doing this randomly, but then you're just going to drag each one as if it's the right definition. Okay. Once you've done the review words, then you actually have new vocabulary. Okay. These are the new words that we are going to be using come the following days, but I wanted to introduce you it while you're working today. Energy, kinetic energy, thermal energy, temperature. And this is a description of thermal and kinetic energy. Okay. And then this is another example of you trying to dive into particles in which state of matter have the most kinetic energy. Okay. I don't want to give you the answers yet. And then between A and B, you're going to just answer, is there more thermal energy in A or B? Okay. Same thing, just a couple more slides diving into thermal and kinetic energy. Then what you're going to do is you're going to drag the correct labels for the huge iceberg. Okay. So which one has more thermal energy, which one has less thermal energy, which one has a higher and lower temperature. Okay. I want to go over what kinetic energy and thermal energy is. So kinetic energy is energy that comes from an object when it's in motion. So anytime an object is moving, it has kinetic energy. The faster an object moves, the more kinetic energy it has. Okay? And thermal energy is energy an object has because of kinetic energy of the movement of those particles. When you heat something up, like you put something on the stove and you see the water start to boil, that water is now gaining a lot of thermal energies. That's why the particles are starting to move faster, eventually turning from a liquid to a gas. Okay, so thermal energy is when you increase the temperature, more thermal energy. When you increase the speed, more kinetic energy.
Done.
Okay. Okay, so if you have any questions, please let me know. But this is your assignment for today, and I'll see you guys later.